house. So this is Tech Math 2. And we're going to do sections 12.3. Oh, that was good. And 12.4 today. Yeah, is that good? So the first issue is we're gonna do graphs of tangent, cotangent, secant, and cosecant. And so that's the plan. So we look at tangent, and tangent is something that goes from minus 90 to plus 90. If I put the xy in the right spot, so I go up to minus 90, I go up to plus 90, and then it's going to repeat itself. And it's going to pass through 180, and then I'm going to leave there. That's 270. I'm going to come up again. So if I'm going to have 2 pi of this guy, I end up having something that goes that way, something that does this, and something that goes that, and that looks like 2 cycles of the function. That being the case, my tangent function period is going to be pi over b instead of 2 pi over b. So if I have something tangent 2x, then my b is a 2, and I divide by 2, and my period would be pi over 2, be 90 degrees. If I had an amplitude in front of this, what's that going to do? Well, that's going to shift where my 45 guy is. So there's my 45 degrees, which is normally at 1. That's going to shift into whatever the amplitude is. Am I going to change the nature of my graph? No, I'm just going to call A where the 1 used to be. That's all I'm going to do. So, and if I have a phase shift, then I've got a phase shift associated with it, but I don't think any of our problem set has a phase shift. Yeah, we do. So we do have a phase shift associated with those guys as well. And we'll worry about that when we get to it. Now, when I do the secant guy, because secant is 1 over cosine, what I do is whatever the secant says, I draw a cosine function doing the same thing, and then I draw my secant off that cosine function. And same thing for cosecant. I know that that's 1 over sine, so I do the same thing that I would have done for sine, and then draw I do a construction of sine, and then I do the cosecant guy. All right, so we'll start with something like, we'll look at the secant of x. All right. And I say, well, gee, that's 1 over cosine x. So I go and I make a graph of cosine x, and I'm going to go all the way up to 1, all the way down to minus 1. I'm going to start at 1, and I'm going to do something like that. I'm going to do something like this, go up and down. And I'm going to repeat myself every 2 pi because my period's 2 pi. There's 2 pi. And we'll come out to here, and there's 4 pi. And we'll come out to there, and there's minus 4 pi. So now I've got my construction of the cosine guy. And now I'm going to do the cosecant, the secant guy. Well, when I pass through 0 with cosine, I'm undefined. So I put some construction lines as I pass through 0. And I don't have to necessarily write these guys down. I can go and pretend like they're there. Sort of like Big Julius pretending that the dice have spots. All right, now I got construction lines passing through 0. And now I can draw my secant curve. So when I'm positive, 1 is going to be 1, and then I'm going to be going up to infinity on both sides. When I'm negative, I'm going to be at negative 1, and I'm going to go down, and then this guy's going to go up. And I'm going to be asymptotic that's a multi-syllable word in case you're wondering, to the construction lines I made. So I'm never going to touch the construction line I'm making, but I'm going to get close to it. So that's what I'm going to do. I'm going to go and one more. There we go. So now I'm going to go and make the cosine curve first and then put the secant curve on top. So remember to bring your crayons for the test so you can do it in multiple colors. And then I'd do the same type of thing if I was doing a cosecant guy, except I would go and graph the sine guy first. Okay, good enough? All right, we'll work problem number 3, just to say we did. And the other thing you do is if you own a graphing calculator, put it in, have it tell you what it is. Just be smart enough that it has whole numbers, it doesn't have pies, right? So 3.1415 is pi, and then make it wide enough so you can see enough. All right, where were we? Number 3. Isn't that lovely? Y is equal to minus 2 the tangent of minus a half x. Okay, well, that being the case, my period is going to be pi divided by 1/2, which means my period is going to be 2 pi. So isn't that lovely? Yes, it is. I've got an amplitude. My amplitude is 2. I got a negative sign I have to worry about. So normally the tangent function is going to do this, but because I have a negative sign, what's on the bottom is going to be on the top, and what's on the top is going to be on the bottom. All right. And what am I supposed to do? Find the period and sketch. All right, so that's all I'm supposed to do. So I already found the period, and now I'm going to sketch it. And I'm going to start high, go through 0, and do that. I'm going to put a construction line there. And I'm going to say, well, normally that would go out to pi over 2, right? But now it's going to go out to minus pi because my period's 2 pi and plus pi. All right, that looks good. And there's 2 right there. And that happens at pi over 2, or 45 degrees. Because pi over 2, it would be minus pi over 2. If I put a pi over 2 times a half, I get pi over 4, which is 45 degrees. Okay, well, that's way too much work. But you could do with a little bit less, as long as you got the period right. Then you realize you're going to have to flop your curve around. Okay, number 10. Do we want to do one before number 10? 5 minus 5 secant. Okay, so if I do that, I do mine, and I do that, then I don't do a cosine one. So I better do a cotangent one first. So we'll do number 5. We have y is equal to the cotangent of 6x. All right, well, my period is going to be pi over 6. Now, the cotangent function is 1 over the tangent function. So if my tangent function does that, and does it again, and does it again over here. My cotangent function does that, then my cotangent has to, when I go through 0, has to be at infinity. Okay, so the cotangent function is going to come down that way and cross this way, and down and across, and down, down somewhere. Here's 0. Okay, so there I'm 0, here I'm 0. going to be at infinity. Oh, I'm not crossing through 0. That's my problem. Okay. So let's see how much of this I can get rid of. All right, that's better. So now I've got I'm coming, when I go through 0, okay, this guy coming, oh well, where's a big eraser? That's better. Okay, so my tangent function's doing that. My cotangent function doing that. All right, my tangent function is doing that. My cotangent function doing that. All right, so that's better. Okay, so my cotangent function is going to pass through 0 at pi over 2 if I had a regular guy. Okay, well this isn't a regular guy. The period is pi over 6. So that means between here and there has to be pi over 6. So that has to pass through pi over 12. Alright, so if that passes through pi over 12, then that's going to pass over through pi over 12 plus pi over 6, which would be 3 pi over 12, which would be pi over 4. Okay, I think that's probably good enough. But we're gonna pass here, that's going to be 1. Because they're both at 45 degrees, whatever the 45 degree spot is, that'd be 1. So this guy here would be pi over 24. And pi over 24 times 6 is pi over 4. Pi over 4 is 45 degrees. Cotangent of 45 degrees would be 1. And I'd be sitting there. Okay. Is that weird enough? Yeah, all right, weird enough. Back to number 10. Okay, so I've got y is equal to minus 5, the secant of x. So my plan is to draw the cosine curve first. Okay, so I'm going to draw a cosine curve. And I know my period's 2 pi. So I'm going to start at someplace. Now, I would normally start my cosine curve at 1. In this case, I have an amplitude of 5, which means I'd start at 5. But it's a minus 5, so I'm going to start at minus 5. So my cosine function is going to start there. Going to go down, going to go up, going to go down, going to go up, go down, going to go up. And it's going to do the same thing on the other side. Up, down, up, down. Okay, so there's my cosine function. And it's going to repeat itself every 2 pi. So there's 2 pi. And there's 4 pi. And on this side I've got minus 2 pi and minus 4 pi. Now you notice that I haven't bothered to construct my secant guy yet. All I did is do a construction of the cosine guy so that it allows me to do the secant guy. All right, now I'm going to put construction lines in where cosine goes to 0. Because where cosine goes to 0, my secant is undefined because I'm dividing by 0 at that point. And you see that I'm being very particular about how straight my lines are and all those other things, right? In fact, I could probably use some of the graphing things to help me out. Okay, now, because I've already flipped the cosine function around, I don't have to do it again for that minus sign. And now I can just put in my secant function. So I'm starting at 5, I'm going up. I'm starting at minus 5, I'm going down. 5, I'm going up. Minus 5, I'm going down. And again, your calculator will do that. Make sure you have a big enough window to see the graph, though.
How do you do that on?
Well, you put it. You just put in y is equal to minus sign 1. You put in y is equal to minus 5 divided by cosine x. So you change the secant to cosine, and then hit the graph button. And then, but you'd want the window open up so that because you got a minus 5 sitting there, you want to go probably up to 50 maybe. So plus or minus 50 on the y-axis and out to maybe 12 or so, plus or minus 12 on the x-axis in your window. So I just happened, you got it? So I'll come back and so y equals minus 5 times secant x x. So I'd probably go plus or minus 15 maybe. And I go plus or minus 50 so I could get a pretty one. Well, isn't that just lovely? Now, why did Maple do that? Well, because Maple has to connect the dots. So I connected the top ones with the bottom ones. Oh, that's terrible. Anyway, so much for Maple. I like my graph better. We'll do number 15. But before we do number 15, we'll do for number 15. Oh, that was good. Highly professional there, I tell you. All right, so we're going to go y is equal to cosecant to x. All right, so first thing we're going to do is make the equal sign look like an equal sign. There we are. Period. What's my period? Well, my period's going to be 2 pi over b. My b is a 2, so my period's going to be pi. Okay, so I'm going to draw a sine function. So there's my sine function. I'm going all the way up to 1, all the way down to minus 1. And I'm going to put construction lines as I pass through 0. Well, that's really professional there too, isn't it? We had a saying, it was as straight as a dog's eye and left rear foot. You ever hear that one? Anyway, probably not. Now, because the period is pi, I go up, I go down, I go to pi at that point. I go to 2 pi at that point. I go down, up, I'm at minus pi. I'm at minus 2 pi. Okay, what color haven't I used yet? Green. Alright, so on the positive side, I'm positive. On the negative side, I'm negative. And I'm sure your crayons will be just as effective at drawing pretty squiggly lines as I am. Okay, enough of that. That was 15. Okay, now we're going to go to section 12-4. Now, 12-4 is slightly trickier in that if you have a graphing calculator, it would just do it for you, and so that'd be cool. But if I had something sine x plus cosine x, well, what I'd have to do is I'd have to make a table. So I'd go and I'd look and I'd say x is going to be something, sine x is going to be something, cosine x is going to be something, and then sine x plus cosine x is going to be something. If I could write that. Alright, so that being the case, when I'm at 0, that guy's 0, this guy's 1, that guy's 1. When I'm at 30 degrees, this guy's a half, this guy's the square root of 3 over 2, and this guy's a half plus the square root of 3 over 2. And of course, I don't know what a half plus the square root of 3 over 2 is, so I have to go and put it in my calculator and find out. And I end up with 1.37. 1.37. Alright, and then I say 45 degrees. Well, at 45 degrees, I have the square root of 2 over 2. I have the square root of 2 over 2. And I could have just put in my calculator and got something else. So I have the square root of 2, which is 1.414. And then I got 60 degrees. And 60 degrees, I got square root of 3 over 2. I've got a half. And I got that same 1.37 again. And then I'm going to have to probably go around the entire circle doing this. So I'm going to look at 90 degrees, and at 90 degrees, he's 1, he's 0, he's 1. And next guy's 120. So at 120 degrees, I'm at a half. I'm at minus square root of 3 over 2. Or is it the other way around? It's the other way around. I'm at square root of 3 over 2 minus a half. Alright, so I take square root of 3 divided by 2 plus 0.5, and I end up, no I don't, minus 0.5. Alright, excellent. 0.37. Then I look at 135. 135. So I have the square root of 2 divided by minus the square root of 2 for the other guy, and I get 0. Then I look at 160, and I've got 1/2, and I've got minus the square root of 3 over 2, and that's probably minus 0.37. And then I look at 180, and I'm at 0, minus 1 for a minus 1. Then I'm going to go another 30 degrees to 10, and I'm going to have a half, minus a half, minus the square root of 3 over 2. Okay, well I already did that adding them, so I can do it subtracting it, right? Minus 1.37. And then I look at 235, 225, which is the 45 degree guy, minus square root of 2 over 2, minus square root of 2 over 2, or minus 1.414. And then what happens next? 15 onto there, 250, minus square root of 2 over 2, minus square root of 3 over 2, minus a half, minus 1.37. And then 270, I'm at minus 10 for minus 1. 300, I'm at minus square root of 3 over 2 plus a half. And then I'd ask myself, do I have that guy? Yes, I do. That's 0.37 minus 0.37. Then I'm going to look at 315, which is going to be minus the square root of 2 over 2 plus square root of 2 over 2, and I get a 0. And then I do 330, and I get minus a half square root of 3 over 2, and I get plus 0.37. And then I'm back to 360, which is 0, 1 for a 1. Okay, then I go and graph this. Okay, so there's pi. There's pi over, there's 2 pi. Okay, so at 2 pi, I start off at 1. At pi, I'm at negative 1. At 2 pi, I'm back up to 1 again. Okay. Now I come back up and I say, well, I go up and I go down. And at 90 degrees, I'm at 1. Okay, so there's 2 pi. There's pi over 2. Pi over 2, 90 degrees. So I'm going to go up and down, and I'm back to there. And then between 90 degrees and 180, I'm going to end up going down to minus 1. And then I'm going to go down and up. And then I'm going to go do something like that. Well, that's a really bad graph. I just tell you right now that is definitely bad. But it's the best we can do under the circumstances. Well, we can do better, right? We can come into Maple and tell Maple that we want it to graph this for us. So you can see what it actually looks like. And so we'll go y equals sine x plus cosine x. Well, we don't have to go all the way up to 5, do we? We can go to minus 2 and plus 2. And we'd like to go plus or minus pi, right? So that gets us plus or minus pi. Well, that's almost what I did. Wow. Thank you, Maple, for being so good to us. All right. So anyway, that's what we have to do. You can put it in our graphing calculator and we can see what it is, or we have to make a table and fill in the table with enough data so that we have some chance of getting something that looks halfway decent. All right, that being the case, we'll look at number 3 next. And darn, I didn't do number 3. But I almost did number 3, right? I can go back and redo it. I can go back. So we'll go and And take this guy. Come on down, you sucker thing. Alright, we'll try it going up. It's not going to do it, is it? Alright, well, that's just the way it is. We'll do it a little at a time. Okay, so we want to copy. Paste. Alright, and then we want, this is number 3. And we want 2 cosine, 2 sine. Alright, so that's what we're looking for. 2 cosine, 2 sine. Alright, and we're already down to 35, so we'll go get the rest of them. Should practice this on a test. 35. Okay, so we'll start at 60. Thank you. All right, there we go. It is that is pretty weird, but can't have everything. Okay, we didn't get all of those guys, so we'll go and erase the bottom part, and then we want the guys past 250. Ah! They're not there. Bummer. We got rid of them already. Okay, well, back to what we're doing. Okay, so we want twice as much. So that's going to be a 2, and that's going to be a 2. We want twice as much. So 2 times that, 2 times that. So this is going to be 2.74. Okay, we want twice as much, so that's going to be 0.8. And this is going to be 2.74. This is going to be a 2. Twice as much, 0.74. 74. The 0 stays the same. Minus 0.74. Minus 2. Minus 2.74. Minus 2.8 minus 2.74. Even though that looks sort of like a 9, it's really a 4. That was good. That was, I like that. All right, am I done? All right, then we'd do the rest of them too. And then we'd say, well, what is this going to look like? It's going to start at 2. It's going to go down to 2. It's going to go up. It's going to go down. It's going to go back up. And when I get done, I'm going to be back at 2 pi. And it's going to go all the way up to 2.8. Wow. It didn't though, did it? Wow. What's wrong with our back row today anyway? Anyway, where's my eraser? And so we erase all these guys because they're all wrong. Alright, so back to what we're doing. The first guy's right. That's 2. But this is 1 plus the square root of 3. And what did I do with my calculator? There it is, I found it. 1, where is it? 1 plus the square root of 3. 2.7. 2.73. I guess I did that right. But this guy's the square root of 2, which is 1.4, not the not the 0.8 I had before. And then this guy here is the same as that guy there, 2.73. And this guy's a 2. And this guy's going to be the square root of 3. Square root of 3 minus a half. So he's going to be a 1.23. And that guy's still a 0. Square minus the square root of 3 plus a half. Minus 1.23 minus 2, 2.73, and so on. So we're going to end up with a graph that goes as high as 2.73 and as low as minus 2.73, and looks sort of like that. Okay, excellent. Good enough? Ben says that's good enough, so it must be good enough. Now I got 12 more minutes to do 2 more problems. So number 9, I want, I'm going to have an x, and I'm going to have 2 sine. And then I'm going to have minus cosine. And then I'm going to have 2 sine minus cosine. That's my plan. Okay, so this time we'll go 0 degrees. That's a 0, that's a minus 1, this is a minus 1. We'll go 30 degrees. This is a half, times 2 is 1. This is minus the square root of 3 over 2. 1 minus the square root of 3 divided by 2, 0.13. 0.13. And then we'll look at 45 degrees. This will be the square root of 2. This will be minus the square root of 2 over 2. Okay, so that'd be 0.7. And then we'll look at 60 degrees. This will be the square root of 3, and this will be minus a half. So square root of 3, I don't have that one. Square root of 3 minus 0.5, 1.23. And then we'll look at 90 degrees. He's 2, 0, 2. All right. So then we're going to have to do it again. Okay, so we're reminding ourselves we need 2 sine, and we want minus cosine. So that's what we're looking for. Okay, now we're in the second quadrant. I'm looking at 120 degrees, and I'm going to be at the square root of 3, and I'm going to be at plus a half. Okay, so square root of 3 plus a half. Square root of 3 plus 0.5. 2.2. 2.2. And then I'm going to look at 135. So that's going to be the square root of 2 plus the square root of 2. All right, square root of 2 plus the square root of 2, that'd be 2.8. 2.8. And then I'm looking at 150. Okay, so 150 is going to be 1 plus the square root of 3 over 2. Oh, I don't think I did this right. This is the square root of 2 plus square root of 2 over 2. Bummer. Square root of 2 plus the square root of 2 divided by 2. 2.12. And now I've got 1 plus the square root of 3 divided by 2. 1.87. And then I've got 180, and 180 is going to be 0, 1, row 1. Okay, then I'm going to have to continue doing that for another 2 quadrants before I get enough answers. What I'm going to do is I'm going to go into Maple and do the curve and put it down and say that we're done. So I can do the next problem, which I hope is easier, but I know it won't be. So I've got y is equal to 2 times sine x minus cosine x. And that's probably okay. We'll go plus or minus 15. Fine. Well, isn't that just special? All right, well, that was great. Number 16. Oh, bummer. Look at that. Number 16 with all of 2 minutes to go. So that doesn't give me enough time to make my table, but that does give me enough time to put it into Maple to see what it looks like. Okay, so I'm going to have y. Where's my y? Y equals sine 2 times x plus cosine 2 times x minus pi over 4. Now I'm afraid Maple's going to have to deal with a pi. I think that's pi over 4, but it might be a capital pi. So we'll try it that way first. No, that's not right. Edit. Because it's calling pi a variable, and pi shouldn't. There we go. Now pi is not a variable. Okay, that's better. Let's go out to. I wonder how far this is going to go. 2 and 2. It's only going to go up to 1. Only going to go up to 2. Okay, so we can go minus 3 to plus 3 on the x. And then we can, well, if we keep it at 5 and it's 2x, that should be okay. All right. Well, that was really exciting there, wasn't it? All right.